All right, my friends, here we are at the final step of this implementation, and actually the most exciting one, because this is the step where we're going to visualize on a nice 2D plot the prediction curve and the prediction regions of the logistic regression model. All right, so more specifically, what we're about to plot is a two-dimensional plot with therefore two axes, x and y. On the x-axis, you will have the first feature corresponding to the age, and on the y-axis you'll have the second feature corresponding to the estimated salary. And therefore, each of the observation points you will see on the 2D plot will correspond to a specific customer. It will either be a customer of the training set, on the plot of the training set results, or a customer of the test set on the plot of the test set results. And what is most interesting to see in this plot will be the prediction regions, meaning the regions where our logistic regression model predicts the class 0, meaning the customers didn't buy the SUV, and the other region where our logistic regression model predicts the class 1, meaning the customer bought the SUV. And lastly, what will be really interesting to see is the curve separating these two regions, the region of the prediction 0 and the region of the predictions 1. And this is exactly how we're going to see the difference between linear classifiers and non-linear classifiers. So here we're only starting with one classification model, logistic regression, so we won't compare that yet, but you will see in the next sections of this part that the prediction boundary between these two prediction regions will be different depending on whether or not your classifier is linear. All right, so I can't wait to show you this, and let's start first by visualizing these training set and test set results for the logistic regression model. All right, so the code to visualize this is actually pretty advanced. And not only it is pretty advanced, but also you will probably never use it again in your career, or let's say you will never have to implement that again. Why is that? It's because in your career you will mostly work with data sets having many features, more than two. And here the only reason why we have a data set of two features is so that we can be able to visualize indeed, these prediction regions and prediction boundary, because indeed in order to visualize this, we need maximum two features, because one feature corresponds to one dimension in this plot. So what I suggest is that we don't waste too much time understanding the whole code and re-implement it ourselves, because really I'm going to show it to you right away. On the original logistic regression implementation, you will see that the code is pretty advanced. It's not like plotting a regression curve like we did in part 2. So that's the test set results. Let me show you the training set results. All right, so that's the code. You see, it uses a lot of tricks to plot all these observation points, prediction regions, and prediction boundary. So if you want to have a look at it and understand it, fine, but really for the others, it's totally okay if we don't cover this code in detail, because this is only for training purposes, just so that I can show you the differences between linear classifiers and nonlinear classifiers, and you will probably never use that again in your future machine learning project. However, what I will do just now is explain how it's done. Basically, what we do is we create, as you can see, a grid, which is basically this frame here containing all the ages of your features and all the estimated salaries, the ranges. And you create this grid with a high density, meaning that the pixels of this grid are not separated one by one, but every 0.25. So here, for example, for the age, it goes this way. It goes from 10 to 10.25 to 10.5 to 10.75 to 11, etc. up to 69, 69.25, 69.5, 69.75, 70. Okay, and same for the estimated salary. It goes from 20,000, then 20,000.25, 20,000.5, etc. up to somewhere around 149,000, 149,000.25. You see, so resulting in having super dense points inside this grid. And then the trick, what we did is not only we plotted all the real observation points in the grid, so all the points that you see here are the customers of either your training set and then later on your test set. The green points are of course the customers who bought the SUV, represented by 1 here, and the red points are of course the customers who didn't buy the SUV, represented by 0 here, okay? So all the points are your observation points, your customers. And then, so the trick, in order to plot the prediction regions and therefore that prediction boundary here, separating the two regions, is to apply the predict method onto each of these dense points in the grid. So that all the dense points here, in this region, were actually predicted to be 0, meaning all the customers, other customers inside this region are predicted not to buy the SUV, and all the observation points in this green region are actually predicted to buy the SUV. So you see how this works? That's the trick. And then really you don't have to understand all the techniques used to implement this, because once again, you will probably never have to implement that kind of code in your career.